Let us solve a question on how to find out the total cost given the information using the Cramer's rule. The question is, a manufacturer producing hats has the following information regarding cost of production of hats. That is, when one hat is produced, total cost is 4, and when 2 units of hats are produced, the total cost is 13, and when 3 hats are produced, total cost is 32. If the total cost function is of form, that is, the total cost function is a function of output which is equal to AQ square plus BQ plus C, where A, B, C are constants, then the value of total cost when 4 hats are produced, that is, when Q is equal to 4, we need to find out the total cost. When 4 units of hats are produced, we need to find out the corresponding total cost. Okay, so let us write what we are being given. We are being given total cost is equal to A Q square plus B Q plus C. This is our total cost. Now when output is 1, and we will write it here, when Q is equal to 1 in this equation, then this equation will become A into 1 square plus B into 1 plus C. That is, we will get A plus B plus C is equal to, what is total cost? When 1 hat is produced, it is equal to 4. Okay, similarly, and I will write it here, when Q is equal to 2, so what will be the total cost? So AQ square, that is A into 2 square plus B into 2 plus C. Okay, so this becomes 2 to the 4A plus 2B plus C. Okay, so second equation will be 4A plus 2B plus C, and what is that? Then the total cost, it is equal to 13. Okay, similarly, and let me rub this out, when Q is equal to 3, then what will be the total cost? That is A into 3 square plus B into 3 plus C. So this is 9A plus 3B plus C. So we write it here, 9A plus 3B plus C is equal to, and correspondingly the total cost is 32. Then we need to solve for when Q is equal to 4. Okay, what will be the cost when 4 units of hats are produced? So we can only find the total cost when we know the value of the constants here. Okay, that means we need to solve these 3 systems of linear equations for A, B and C. For that, what will we do? First thing is, we write the given system of equations in matrix form. That is, A x is equal to B. Okay, and I will explain what is A, B and C. So A is the coefficient matrix. Okay, so let me see if I am inside the space. Yes. So the coefficients of A is B and C is denote the coefficient matrix. So the coefficient of A in the first equation is 1. In the second equation it is 4. In the third equation it is 9. Similarly, the coefficient of B in the first equation is 1. Here in the second equation it is 2, and here it is 3. And then the coefficient of C are same, that is 1, 1 and 1. This denotes our coefficient matrix. Okay, what is x? X is the solution vector. That is, we want to find out the value of A, B and C. It should be equal to the vector of constant terms. What are the constant terms here? That are 4, 13 and 32. Okay, to solve for, to find out the value of A, B and C, first we write the given system of equations in the matrix form in such a way that A into x is equal to B. A is the coefficient matrix, x is the solution vector and B is the vector of constant terms. Then to solve using the Cramer's rule, first thing is we need to find out the determinant of the coefficient matrix. Okay, since A is, what is our A? Let's rewrite A. So our A is this very matrix: 1 4 9 1 4 9 1 2 3 1 1 1. This is our coefficient matrix. First step is to find out the determinant of this matrix. Okay, how do we find the determinant? Simple thing: we write the first element and mentally delete the row and the column in which the first element appear and take determinant of the remaining elements. Okay, so since first element is this, so we delete this row and this column and take determinant of the remaining elements. So remaining elements are 2 1 3 1. So what is the determinant of this very matrix? 2 3 1 1. You can see. So 2 ones are 2 minus. So we multiply these two elements, then subtract and multiply these two elements. Okay. Then we write minus from the formula and write the second element, that is 1. In this case, when we have the second element, we mentally delete the row and the column in which it appears and take the determinant of the remaining elements. What are the remaining elements then? That is 4 9 1 1. Okay. So what is the determinant? That is 4 ones are 4. Then we subtract and multiply these two elements, that is 9 ones are 9. Okay. Similarly, we write plus 1. Okay, first we write plus 1, then we write minus 1, then we write plus 1. So sign changes alternatively. Then we write the third element and mentally delete the row and the column in which it appears and take the determinant of the remaining elements. So remaining elements are 4 2 9 3. Okay, so 4 3s are 12 minus 9 2s are 18. Then we solve this. So here you can see 2 minus 3 is equal to minus 1. We have 4 minus 9 is minus 5. Minus 5 into minus 1 is plus 5. Then 12 minus 18 is, I guess 12 minus 18 that is equal to minus 6. Minus 6 minus 1 is minus 7. Minus 7 plus 5 is minus 2. Rather, the determinant of coefficient matrix comes out to be minus 2. Okay. Now what we need to do to find out the value of A, okay, and let me write it here. To find the value of A, we form a new matrix let us say A1 by replacing the first row of coefficient matrix. Okay, coefficient matrix with the vector of constant terms and take determinant of A1 such that the value of value of A will be equal to the determinant of the new matrix which we form divided by the determinant of the coefficient matrix. Okay, I thought it was necessary to write it here. Okay, now how do we find out A1 then? Let's write. So A1 will be our new matrix, okay, which will be formed by replacing, to find out the value of A, let me repeat it here, we replace the first element of coefficient matrix with the vector of constant terms. So we will have 4, 13 and 32, 4, 13 and 32, we are replacing 149 with 4, 13 and 32, and rest we write same. We have 1, 2, 3 and 1, 1, 1. 1, 2, 3 and 1, 1, 1. Okay, now we take the determinant of this very matrix. So determinant of A1 will be equal to, same thing applies. We write 4. I explained it here. How do we take determinant? I will not explain it here. Okay, so we write 4. Delete these rows, so we get 2 minus 3, 2 minus 3, then we have minus 1, deleting this row and this column, so 13 minus 1 is 13, minus 32, 32, then we have plus 1, deleting this and this, so 13 into 3 is 39, minus 32 into 2 is 64. Solving this, so A1 will be equal to, so 2 minus 3 is, okay, since we are 2 minus 3 comes out to be minus 1, so we are left with minus 4. Here 13 minus 32, plus, so it is minus 19, minus into minus is plus 19. Then we have 39 minus 9 is 5, sorry, 5, 64, let me write it here, 64 minus 39, 5, that comes out to be 25 but minus. Okay, adding this up, so A1 will be equal to, this is 29 minus 29 plus 19, which comes out to be minus 10. Then the value of A will be equal to the determinant of this A2 upon the determinant of the coefficient matrix. So it is here minus 10 upon the determinant of A, we got minus 2. That means the value of A will be equal to, minus minus gets cancelled, so we will get 5. That is, A will be equal to 5. So we are done with A. Now in the same manner, to find out the value of B, we replace the second column of the coefficient matrix with the vector of constant terms and form a new matrix A2, that is. So to find out the value of B, we replace second column of the coefficient matrix. So first column is 149, 149, and in place of 1, 2, 3, we write 4, 13, 32, 4, 13, 32, and then we have 1, 1, 1, 1, 1, 1. Then we take the determinant of A2. So A2 will be equal to, the determinant of A2, by the same logic, we write the first element, delete this row and this column, so 13 minus 32, 13 minus 32, then we have minus from the formula, then we delete this row and this column, so 4 minus 9, 4 minus 9, then we write plus 1 and delete this row and this column, so 32 into 4, 4 2s are 8, 4 3s are 12, so we get 128 minus 9 3s are 27, so 9 1s are 9, 10, 11, so we get 117. So the determinant of A2 will be equal to 13 minus 32, it will come out to be minus 19, then 4 minus 9 is 5, minus 5 into minus 4 is plus 20, then 128 minus 17, so we will get minus 11 here. So this sums up to be 9 plus 9 minus 19. Okay, let me see. 20 minus 11 comes out to be okay, we got minus 19 plus 20 and minus 11. Okay, so let me see what happens here. So 20 minus 11 comes out to be 9, so we have, okay, let me see if I have done it correctly or not. It should be equal to 20 minus 11. 20 minus 11 is, so we have minus 19 plus 9, so I guess it is equal to minus 10. So okay, so I was just getting confused about these numbers. Then the value of b will be equal to the determinant of a2 upon the coefficient matrix. So a2 is minus 10 upon minus 2 which comes out to be minus 5. Okay, so rather it comes out to be 5 here, but I have some reservation here. I have done a mistake, I guess, somewhere. Sorry. Let me see. So we have minus 19, here we have minus 19, then we have minus into minus is plus 20. Okay, then we have plus 11 here. Okay, plus 11 I guess here. So what will we get? 20, and it comes out to be 31 minus 19. So 11 minus 9 is 2. Okay, why I'm getting stuck here, I don't know. So 2 minus 1 is 1. So actually we are getting 12 here. Plus 12. I hope I have done the correct calculation here. So then the value of b will be equal to a2 upon a. So a2 is 12 upon minus 2. Okay, should the value of b be negative, what we are being told here, a, b, c are the constants, so we are not being told whether they are integers or whole numbers. Okay, so this comes out to be minus 6. Okay, simple thing. To find out the value of b, we replace the second column of the coefficient matrix with the vector of constant terms, and then take the determinant of this very matrix, and to find out the value of b, we divide it by the determinant of the new matrix with the coefficient matrix. So the value of b is equal to minus 6. By the same logic, we can find out the value of c by replacing the third column of the coefficient matrix with the vector of constant terms. Okay, and then forming a new matrix a3. Okay, so by the same logic, but we don't need here because we got two values a and b. We can find out the value of c very easily. But to explain it, to find out the value of c, we replace the third column of the coefficient matrix with the vector of constant terms. The value of c will be equal to a3 upon a. Okay, but we are not supposed to do that very calculation. You can check it by yourself. Now what we are being given here, a plus b plus c is equal to 4, and we know the value of a and b here. That means, so in place of a, I will write 5. In place of b, I will write minus 6. Plus c is equal to 4. So 5 minus 6 is minus 1, plus c is equal to 4, or c is equal to 4 plus 1, or c is equal to 5. Okay, so since we have found out the values of a, b and c, now we can find out the cost of producing 4 units. Then when q is equal to 4, sorry for my English, so when 4 heads are produced, then what will be the total cost? As we know, the total cost is a function that is a q square plus b q plus c. So we can write, in place of a we have 5, q square means 4 square, plus b is minus 6, let's write it here, minus 6, then minus 6, and q is 4, plus c is 5. Okay, so this is 4 4s are 16, 5s are 16, 5s are 5 6 are 30, 5 1s are 5 6 7, 4 4s are 16 and 5, so it comes out to be 80. Okay, so we have 80 minus 24 plus 5, so this is 85 minus 24. So what is 85 minus 24? 85 minus 24, 5 and 4 of 8 and is the 61. Okay, so total cost of producing 4 units of heads will be equal to 61. So here it should be 61, or rather here it should be 61. Same thing here. I hope I make myself clear in this video. Thank you.